aware of, there's a great American eclipse, and I came up with this double header. I didn't find this on the internet or anything from baseball, because we have two of them. Can you all see my cursor? Can you all see my? Yeah.
Yes, sir.
Yes.
So we have one October 14, 2023, an annular, and another one April 8th, 2024, which is a total. And October 18th is my birthday, so this is a celestial birthday present for me. So the annular that goes to the left is going to last 4 minutes and 29 seconds. The total that goes to the right is going to last 3 minutes and 50 seconds, so average about 4 minutes. Now, the last total eclipse, as you know, was August 21st, 2017. And if anybody has any photos from that or other eclipses you've been to, if we have time at the end, feel free to show them. I'd like to see them. I mentioned that in an earlier email. So the next total eclipse in the US will be August 23, 2044. I'm going to be 85 years old. So I hope I make it that far. So you have to see these, and in my opinion, try to see both. I know the total is coming right in your backyard in the Northeast, but you want to see both, because you could say you've seen the Great American Eclipse double header. That's something, and that's rare. That's never happened before. We had two major eclipses, solar eclipses, 6 months apart. I mean, it's really incredible. And so if you don't go for the annular, the entire US will experience a partial eclipse on both occasions, depending on where you are. But like I said, don't miss this once in a lifetime event. Okay, so there's 3 types of solar eclipses: annular, total, and hybrid. And actually tonight in Australia, there's a hybrid eclipse happening starting 9:30 our time. So this is the rarest type because it shifts from a total to an annular as the moon shadow races over the earth. So some locations will see a total, others will see an annular. You want to position yourself where you actually see the total. And in all cases, you must travel to see and experience this celestial phenomena. And I see it this way: it's not merely a vacation, but an adventure pre-planned by nature. Like, you have no say where you're gonna go. This is the path. So you want to pick, this is your choice right here. So you can see the eclipse. So you can't pick any other area, or else it'll be partial. See, so it's kind of pre-planned for you by nature. It's really, really incredible. Okay, so first we'll start with the annular solar eclipse. And solar eclipses, all of them, total, annular, and hybrid, only occur during new moon, when the moon is between the earth and the sun. The sun's out here, you can see it's lit. Here's the moon and the earth, and then as it orbits the earth here, it has this thin strip, which is the annular or the total eclipse. Now, lunar eclipses happen during a total eclipse, a total, when the moon is total phase. And what's great about lunar eclipses is the whole hemisphere will see it. So when we can see in the United States, South America can see a lunar too, but that's not true about a solar, okay? And actually, solar eclipses happen more often than total lunar eclipses, but the path is so narrow, you have to travel to see it. Okay, so the moon and the sun have the same angular diameter in the sky, about 30 minutes, arc minutes. Thus, the eclipse can occur. And during an annular, the moon's diameter is slightly smaller because, sometimes being the Earth's, the moon's orbit, perigee and apogee, perigee, apogee, a little further away, it's a little smaller. And so it doesn't completely cover the sun. And so you get an annular eclipse or a bright ring, okay? Annular means ring shape. You can't see the corona. And you need to wear these eclipse shades throughout the entire time. And these are the eclipse shades here. You can't see a thing with them on, but you really need to get these. And the thing is, you better get them now because they're selling out fast on Amazon and any other. I'll talk more about this later, but they're going to sell out fast for the annular and for the total. So if you don't have any now, you're not going to get them, and you really need them to see both eclipses. Okay, so here's the annular eclipse. See, I put the sunshine, the eclipse goggles to remind you. So here's where it's going to be. And I have a trip planned by Ring of Fire Expeditions. I'm going to be in Utah to see the total and the annular. And notice Connecticut's only going to be 20%. So you're only going to see a little more than this. You're not going to see very much, unfortunately. You're just going to see a little piece of it. So that's why I'm saying, just hopefully you have some relatives that live along here, or take a trip to Vegas. Good idea. Nevada. Oh, actually, Nevada's in the path. So right there in New Mexico or Arizona. Okay, so or Texas. I mean, don't go to Oregon. It's probably going to be cloudy. But down here, these are more desert states. That you want deserts. They tend to be clearer. That's the best climate. And here's what you'll see, a nice little ring around the sun. It's really beautiful. And then here it is, as you see it. And we'll talk more about these little, they call Bailey's beads later, okay? So that's it for the annular eclipse. Any questions before we move on? You can jump in at any time with questions, okay? So I don't get derailed by that. But please try to see the annular. I know the annular doesn't give you the same wow, that a total does, but it's still very worth seeing, especially when they're 6 months apart in your own country. I mean, that's fantastic. I said apart in your own country. See, I'm from New England, Rhode Island.
Good catch.
Huh? Good catch.
Good catch.
Okay, so.
Oh, let me just add, since you've been talking about eclipse glasses, that my friends over at Daystar have just within the last few weeks bought all the equipment to make their own Mylar glasses.
Oh.
So they are ramped up to fully produce and various different shades of, USA and, other type of graphics printed on them. But they were doing all the work in-house now, instead of having to buy the solar film from someplace like Batter or Thousand Oaks, which they have been doing for the bigger plates and the glass plates. Now they're making their own. They got the equipment.
Oh, fantastic. Okay, so hopefully they'll produce a lot so everybody can get one. Okay, so now we're going to total lunar eclipse, and a total lunar is basically the same. It still occurs during new moon, when the moon is between the earth and the sun. And now the angular diameter of the moon is larger, so it's actually able to cover the whole sun for a few minutes. The maximum that it can, the maximum eclipse is a little over 7 minutes. And that occurred in 1991, which was the first eclipse I went to in Hawaii, and it was clouded out. Can you believe it? And then after after totality, then it cleared, so I got to see the partial phases. Somebody's on, it's not muted. And then okay, so
those things you change. My signature.
Are you hearing somebody else?
Yes. No. Yes. It's. Hang on. Let me mute my PC. My wife is in a conference.
Oh, okay. All right. Now we don't hear it. Okay. So and total lunar eclipses can be very scientifically valuable. The total lunar eclipse of May 29th, 1919 was used by Sir Arthur Eddington to verify Einstein's general theory of relativity. That was the first verification, because he observed stars near the sun would displaced from their normal positions as predicted by relativity. Okay, so, and question, why a lunar and solar eclipse is not a monthly event? Can anyone tell me?
The angle of the ellipse, the elliptical orbit of the moon is offset from the equator of the Earth.
Yeah, very good. By how much, do you remember?
No.
No, all right. Here it is. 5.4 degrees, 5.14. So that's exactly right. Thanks, Bill. So here you have the Earth, and here you have the moon. Here's the orbit of the moon. See, it goes above and below the Earth's orbits here. If it stayed here, then we'd have an eclipse, solar eclipse every month. And when it's over here, we'd have when it's over here, we'd have a lunar solar eclipse. And then when it's over here, we'd have a lunar eclipse. So, but the fact that it's inclined 5.14 degrees, it misses it. Okay, so that, and in a way, it's a good thing because if it happened every month, we had a total lunar eclipse, it would be no big deal. How many people get say, "Oh my God, it's a full moon! I'm going to wait. I'm going to go outside and watch it for hours." Right? Nobody does. But when a total lunar eclipse happens, everyone's excited because it's not an every day or every month phenomena. See, so in a way, it's a good thing. Okay, so that's the reason it's inclined 5.14. Okay, so sometimes it's above and below the plane of the ecliptic, which is where the sun is. So the shadow misses the Earth, or the shadow cast by the Earth misses the moon. Okay, so now there's another thing, a node. You notice you have these nodes here. And what a node is a point in space where the sun's orbit, which is the ecliptic here, crosses the moon's orbit. So each time the moon completes an orbit around the Earth, it crosses the Earth's orbit at a point west of the previous node. So each year the nodes regress 19.4 degrees, making a complete revolution 18.61 years. And the solar eclipse will thus occur at the same part of the sky, the location of the Earth. This is known as the Saros cycle. Okay, so here we are. Here's the node. So every month the nodes move 19.4 degrees west, okay? And then in 18.61 years, this node would be over here and this node would be over there. Does that make sense? And that's what's called the Saros cycle. And in 1991, remember I said Hawaii, I saw that was the longest 7 minutes. The next longest was in 2009 in Shanghai, China. And I went to that too, and it was clouded out. It was actually raining that. So the two longest eclipses were clouded out. Talk about dumb luck, but that's what happened. So does everyone kind of understand this? This is the most complicated slide here. So if anybody can maybe explain it better, feel free to jump in, or is everyone good with this explanation? So basically, we have it inclined 5.4 degrees where it crosses the moon's orbit, crosses the sun's orbit is called the node. And then every month, these nodes move west, regress 19.4 degrees, and then in 18.61 years, this node will be over here and this will be over there. So that's all it's basically saying, okay? And that's called the Saros cycle. Okay, a total lunar eclipse in your backyard. New Englanders, yard. I said yard. A total lunar eclipse in your backyard. Look at this. You guys are so lucky. You have one right, in your back, and at a good time too. One thing about solar eclipses is you want them like in the afternoon. You don't want them early morning as they're rising. It might be aesthetic, but a lot of times in the morning you have like clouds along the horizon, and same thing at sunset, because you know the air turbulence starts, you know, the weather, you know, gets warmer or cooler, you know, and so you get a lot of clouds forming, condensation, and that's going to ruin the eclipse. See, but when it's usually high up near the zenith, you don't have too many clouds. If the clouds are at the zenith, you're pretty much completely clouded out. So, you know, it's a good thing. So you got it at a really good time. Look at that. So 3:15 down here, and then by Maine, it'll be like 3:30 or so. I recommend that ASGH form a committee and try to get maybe a carpool together, figure out where you want to see it, research which area has the best climate, like in April, look now, and see, like, you know, climate for Vermont, for New Hampshire, for Maine, you know what I mean? Whatever's here. Oh, and when you're here, you want to be in the center. They call the center line. If you're more toward the edge, you're going to get less eclipse. Okay, you'll see more Bailey's beads, but you'll get less eclipse. Okay, so you want to center yourself as much as possible. If you're a little off center, that's fine. But if, see, you don't want to be here and see Burlington right here. Plattsburgh is really nice. You're right on the center. If you're here a little bit, it's not too bad. But you don't want to be here in Montpelier because you're right near the edge. So you're not going to see the full, how many minutes is it? I had it here, 3 minutes, 50 seconds. Okay, so almost 4 minutes. You're probably only going to see 1 minute if you're over here. Okay, so you want to center yourself as much as you can. Okay, so and I know it may be a little bit of a drive to go here from Connecticut all the way up to Vermont and New Hampshire. Maine's the furthest, but do it because if you went, how many people have seen the 2014 eclipse? Yes. All right. So
2017, you mean?
2017, I'm sorry. Yeah, 2017 eclipse.
Yeah, I went down to Laurel, South Carolina for that one.
Oh, good, good. So Laurel, South Carolina, going up here is not too bad. You know, that's not that much of a drive. How many hours? About 3 hours or 4 hours up here. It's not too bad. So
3.5, 4. It's pretty far up there.
All right, yeah, but do it, all right, because it's well worth it. So you guys are lucky you have one right in your backyard. But how in April are the climate? How's the weather in New England? Is it bad? Is it usually very cloudy? What, rainy? What is it?
Hot luck.
April showers bring Mayflowers.
Mayflowers, yeah, yeah. And here I'm going with another group, and we're going to be in Uvalde, Texas, where that unfortunate incident happened. So we're going to be in Texas, and notice Texas is kind of the chosen state because here's the annular and here's the total, right in this San Antonio, Texas. It's really cool. So if you live in San Antonio, you don't have to go anywhere. You're going to see both of them. So that's pretty cool. Okay, and here's the animation of the total, as you well know. Okay. And okay, so these are all the different stages of an eclipse. So first contact is when the moon first begins to cover the limb of the sun. And you need these eclipse shades to view it. And you see a little nick come, and that's first contact, okay? Now the crescent sun, you get partial phases. So over approximately 90 minutes, an hour and a half, the moon obscures more and more of the sun. The sun appears narrower and narrower crescent. So you need these eclipse shades the whole time. And like I said, purchase them now. And you'll notice that about 15 minutes before totality, when you have a nice thin crescent, the sun is about 80% covered. The light level noticeably decreases. It starts getting really, really darker and cooler. You sense a perceptible temperature drop, and the landscape appears to be darkening, especially along the horizons. So everything looks really cool. And then and then along the western horizon, it'll get darker, like a thunderstorm's approaching. And then you'll hear insects. All of a sudden, you start to hear like crickets. I've heard that too. Crickets start chirping. They think it's like getting nighttime now, and it's really cool. And then sometimes you see birds start to fly, and they're all confused. Why is it getting dark? It's midday, and then the insects and birds become anxious. They think night falls across. And notice how people are behaving around you, because usually you don't go yourself, you go with a group, especially if it's to some exotic country. And so people start reacting, oh, wow, hey, everybody's getting all excited and stuff. And then what you'll see is what are called shadow bands. And these shadow bands are thin wavy lines of alternating light and dark that are undulating. And they're due to fine air turbulence that are refracted through sunlight, okay, because of the narrow crescent. And the thing is, I've been to several eclipses and people were yelling shadow bands. I looked really quick. Don't bother looking for shadow bands, in my opinion, because it's totality when you get shadow bands. So you don't want to be looking down and seeing just a little thing like this. Okay, you want to see the corona, and it's moving, and so if you're going to sacrifice anything, sacrifice the shadow bands. I usually don't really bother. If somebody yells shadow bands evident, I'll really quick for like 2 seconds and then I'm back up, so I can't really say I've really seen shadow. Have you guys ever seen shadow bands during the 2017 eclipse? You have, John? All right. So totality, Bailey's beads. So near the beginning and end of total and annular eclipse, the thin slice of the sun appears to be broken up by globs of light. These are called Bailey's beads after Francis Bailey in the 1800s. And these are due to rays of sunlight passing through deep valleys in the moon's limb. See that? You can see, so there's a valley there, a valley there. Isn't that cool? And then when just one is visible, they call it a diamond ring, because it looks like a diamond ring. And this is actually one of my photos. It's from a video still, actually. And the moon covers all but one of Bailey's beads. This is called a diamond ring. So the moon's dark shadow now rushes forward and engulfs the sun. When the last bead vanishes, totality begins, also known as second contact. Do not look directly at the diamond ring. It'll hurt your eyes from personal experience. What happens? See, you see this coming in, right? But going out, you get a diamond ring too. And I'm watching now. You can take your eclipse glasses off during second contact, okay? And what happens is you don't know when this is coming back for third contact, when the eclipse ends. And on one eclipse, I think it was the one in Chile, in 2017, and the diamond ring just came out, and I was staring at the sun. Oh, it hurt my eyes, and I saw like a white center. My vision was fine, except one white center scared me. But fortunately, it came back within 15 minutes or so. But it scared me, man. I mean, it's like a laser going right into your eye. Be very, very careful, especially because you see it going out, so you know to not look at it directly, but you don't know when it's coming. I mean, you know when it's going in, but you don't know when it's coming out. You see it brightening and brightening, and all of a sudden, boom, it just appears fraction of a second in it, and it can really hurt your eyes. So be very careful with
Greg,
a diamond ring. What?
Question there is for an annular eclipse, as the moon moves across the face of the sun,
Yeah.
do you also see something like a diamond ring effect and Bailey's bumps?
No. You see Bailey's beads. You see this, like this is an annular here, and you'll see Bailey's beads, but you keep your sunshades on 100% of the time, the whole time when you're seeing an annular, you never take them off. Even during annularity, I've looked really a fraction of a second and it's still very bright. You cannot just stare at it, okay? So you still have to put your glasses on 100% of the time. So you don't have to worry about any diamond rings here or any of these, you know, hurting your eyes, because this is on 100% of the time during an annular, okay? But during a total, if you keep these on during a total, you're not going to see it. You're going to take them off. And when you go with a big group, people will say, I've gone with, you know, Fred Espenek and Mr. Eclipse, his website, and Dave Levy, the Shoemaker Levy Comet Discoverer. And a lot of times they will yell, glasses off, totality, glasses off. They'll say glasses on, you know. So they'll tell you, you know, you'll have experts telling you exactly when to put them on, when to take them off. So that helps a lot, especially if you're a novice, okay? And none of us here are novices. So during second contact, once the diamond ring disappears, you see what's called the sun's photosphere is completely covered, okay? And now it's safe to look at it naked eye. So what you see is what's called a chromosphere. Chroma for Greek, I'm Greek, so chromosphere is chroma actually. And so that the chromosphere, the colored sphere, is red because of hydrogen gas, okay? And prominences appear. And what's cool is before hydrogen alpha telescopes became available to amateur astronomers, only professionals had, you know, these things. You know, the only time you could see a prominence was during a total solar eclipse, but now you can see them every day because Coronado, Lunt, Daystar all make fantastic hydrogen alpha scopes. I have a Coronado myself, 60 millimeter, the Solar Max 2. So I mean, I look at it, it's just fantastic. So you don't need, you know, a solar eclipse now to see a prominence. You can see it every day, you know, with your hydrogen alpha scope. And the corona is white, and this is only visible during totality, okay? You'll never see the corona, only during totality. This is how it looks. And what is cool is when you take photographs of this, it's usually, you have these beautiful, look at this, you have these beautiful fine streamers and they're moving in real time. You can see them moving. It's just so beautiful. It's indescribable. And see, when I took it, only the outer ones you can see detail. As you get closer, see, it overexposes. So even with the best cameras, so people, what they do is when they take photos, they take the inner corona and then they take photos overexposing this to get the outer corona, and then underexposing, and then they combine the two. But you know, that's more advanced stuff. But it's just, this is how it looks like. It's so beautiful. And here you can actually see the poles of the sun. They're right here. See it? Because this is like a bar magnet. This is the streamers coming through. Isn't that cool? And there's a prominence. See, there's two prominences there because you're looking at the photosphere, and some smaller ones there. And then look at that. That is just, this is exactly what the eye sees. And Fred Espenek takes beautiful pictures like this. And okay, so when the eclipse of the sun is total, a solar corona can be seen, this white halo around a black disk of the moon. And then the light comes from glowing atoms, partially from sunlight scattering off electrons and dust particles. And the shape and size of the corona varies with an 11-year cycle, as you know. And eclipses are important for studying the solar corona. Yeah.
Is that one of Fred's pictures?
Probably is. Yeah. It's not, doesn't have his name on it, but yeah, I'll bet it is. Yeah. And so second context, like I said, the corona and prominences here vary with each eclipse. Is the corona round or broader at the equator? Can you trace the solar magnetic fields? See, here's the solar magnetic fields right here. See, this is all, magnetic fields guiding all this. It's just so beautiful. And then each eclipse creates its own level of darkness. Some eclipses are darker than others. Temperature is lowest during totality. What insect and animal sounds do you hear? You know, so you'll hear animals reacting, birds, insects. What human reactions? Everyone's going, oh my God. Everyone's freaking out. It's just so beautiful. And also look and see, you may see stars and planets that are nearby the sun. Remember, Sir Arthur Eddington used stars near the sun during the 1919 eclipse to confirm Einstein's theory of relativity. So look for some planets and stars around. Okay, so third contact is the edge of totality. The western edge begins to brighten. The reddish prominences in chromosphere begin to disappear. And then one bright dot of the sun's photosphere returns to view, diamond ring. And this is what can hurt you, right? Totality's over. Now you need to put eclipse shades back on. So only during totality do you take them off for 3 minutes and 50 seconds. And the eclipse shades are required for the remainder. And then the stages of the eclipse repeat themselves in reverse order like this. Okay, and then you have recovery of nature and partial phases. This just absolutely astounds me. Partial phases, many lose interest. Everyone's excited as the sun is going from, 5% to 20 to 30 to 90%, 99%. And once after totality's over, right, the sun is still 99% eclipsed, right? And everyone's breaking out champagne, getting cigars out, hugging each other, celebrate. No one's looking at the sun anymore. It's 99% eclipse. It's 90%. It's 80%. No one cares anymore. And I'm like, what is going on? And I spoke with Fred Espinick and I go, what is the matter with people? Why does, and he goes, I know, Greg, it's amazing, isn't it? He goes, I have to, he said, because NASA's paying me to be out here, to videotape and to photograph the entire eclipse from beginning to end. So he goes, I have to do it. But he said, he goes, you and I are probably the only ones doing it, he said, from beginning to end. I go, I look at it as it's a process. It's, it's not fine. Totality is the ultimate, but after that, I mean, God, it's just people lose interest in the sun. It's still 90, 80, 70% eclipse. If you have a 90% partial eclipse in your area, you'd be out there looking and all excited. But after totality, people just lose interest. I mean, it just blows my mind. I'm still, and then sometimes it upsets me too, because during the partial phases, everybody wants to pack up. And so a lot of times I would still have like 25% of the sun eclipsed, but we're in a bus and we're out in the middle of nowhere. And, I got to pack up or else they're going to leave me there. So, I end up missing, 20, 30% of the sun, but, totality. Not totality, but the partial phase is going out after third contact. But that's how the story goes. But and then oh, what happened? Oh, Sharon is paused. What happened?
What's wrong, Greg?
I don't know. It says sharing is paused here.
We still
Stop.
see we still
right,
see stages of an eclipse, but you stopped it.
All right. Well, let me. Wait, where is it? Oh, wait. I gotta bring it back up again. All right. All right. Let me. Here it is. Share. Okay, everyone can see that. Okay, so fourth contact, it's over. The last snip goes, and then the sun appears as it would look any normal day. So the eclipse is over. All right, so just want to mention the solar corona, like I mentioned, changes, varies 11-year cycle. We're
I'm
currently
sorry, Greg.
Yeah.
I'm sorry, was there a third contact screen that I didn't see? We're at fourth. Was there a third?
Second, third, right there.
Okay,
Yes,
just wondering if there
yes.
was an image I missed.
Yeah, there's
It's-
third contact.
Okay, thank you.
You have totality is over on third contact and fourth.
Okay.
Yeah. And then everything goes back in reverse order, and then fourth contact, it's the whole eclipse is over. Okay, so solar corona varies 11-year cycle. We're currently approaching solar maximum. So in 2017, we're solar minimum. So during solar minimum, as you know, you have fewer sunspots, and the corona is fairly simple, basically outward or low latitude regions of the sun's equator. And during maximum, it's just everywhere because it's a lot more chaotic. Okay, and like I said, photographs don't show the intricacy of the streamer. So this is the way the sun would look during minimum. The corona would look more typically during minimum, like in 2017. See, they're more near the equator, the corona, and then here during solar maximum, they're all over the place because there's a lot more going on in the sun. And then continual monitoring before satellites and everything, the only time scientists could study the solar corona was a few precious minutes during a solar eclipse, like during Eddington's Day. But now there's SOHO. That's a cool day, SOHO, Solar Heliospheric Observatory. This is a spacecraft that carries this LASCO, large angle spectroscopic coronagraph. And what it does is it has 3 coronagraphs, and it puts a disk in front of the sun so you can continuously monitor the solar corona. And I actually have an app of that, so I could look at the solar corona on my SOHO. See, so I can look at it. I don't know if you can see it, but right there, that's SOHO right there. So it tells you what the solar corona looks right now. So we don't need a solar eclipse anymore to see prominences, to see the corona, but it's still cool to see. And then, they measured, solar corona is measured in terms of solar radii. And then once solar radius is 420,000 miles. And then, so why study the corona? First, study how the sun works. All energy leaves the sun through the corona. One thing that still isn't understood is the corona is actually hotter than the surface of the sun. It's 2 million degrees Celsius. So nobody knows why this corona is so much hotter than the sun. The best theory is coronal heating via magnetic fields. The second, study the corona to learn more about the Earth, is coronal mass ejections. And these can cause aurora and shortwave and communication blackouts, and all that happens. And solar coronal mass ejections happen all the time. SOHO always I subscribe to spaceweather.com, and it comes out every few days. And whenever there's a coronal mass ejection, they'll show it and everything else. They will show beautiful videos. This huge mass just is ejected. It's amazing. And then third, the sun is a typical star, a G star. So studying the sun close up, we gain information about stars that are merely pinpoints in our largest telescopes. And also the sun is a celestial laboratory. It's a perfect vacuum out there. So the corona is hot plasma, which is an ionized gas. You remove the electrons from hydrogen. And it's H plus, that's an He plus, helium, that's a plasma. And they're shaped by magnetic fields. And also you can take what are called flash spectrum. I'm gonna try this year. This one's by Fred Brunges. You must know him, John, from Daystar. I met him and Jen Winter. We've been on a few eclipses together.
Yes, indeed. He also wrote the software Eclipse Orchestrator.
Yeah. But bright guy, sharp guy. So so tips for observing the Great American Eclipse doubleheader. Okay, so the annular eclipse will take place on October 14th on a Saturday. So always look what day, the universe doesn't understand human work schedules. Okay, so in this case, we're lucky it's on a weekend. So that's fantastic. So, but the total eclipse, you're not that lucky. It's on a Monday, all right? So that's a work day. I know many of us may be retired, but a lot of us are not. So you need to make sure you take sufficient time off for work. So if you're only going to northern New England, all you need is Monday off. That's it. But if you're going to travel like me, you're going to have to take a week off. So make sure you take sufficient time off for work. Travel ahead of time to the nearest city near the center line where totality will occur to find your observing spot. No excuses, spot. No excuses, just do it. This will turn out to be a venture of a lifetime. Take GPS coordinates of the site. Now I have a cell phone app that does GPS coordinates. Before I bought a special GPS monitor. But this is important. There's going to be traffic like crazy. You need to find a good spot where you're going to observe the total solar eclipse. Okay, you got to pick your city. You got to find a good observing spot. If you go with an organized group like I do, they do all that stuff for you. But I remember my first eclipse that I actually did see was an annular eclipse in 1994. And we went to El Paso, Texas. And I remember setting up in a church parking lot. I figure our church is a safe place and everything. It had nice horizon looking east, and it was toward the early about 11ish or so. And then I got there like 4 a.m. because I wanted to polar align my scope really well. So I brought an 8-inch Mikasa grain and I can show you the videotape. It's on YouTube. But what ended up happening, make a long story short, police officer came up and he says, "What are you doing here?" Okay, because he sees, 2 telescopes set up and all this equipment. And I go, "Officer, there's an eclipse." And I gave him some glasses. I always have extra glasses for people. And he looked and he said, "Oh, wow," and all that. And he said, "Next time you need to let us know that you're going to be here." And I said, "Oh, it's only going to be a couple more hours and I'm out of here." Looking at me, I'm no threat to society. So he let us stay. But I mean, if you're going to be in like a public place, parking lots and all that, check with the local authorities and let them know you're going to be there. Being the big eclipse doubleheader, they'll probably already know. So, you probably don't have to do that. But that surprised me. A police officer came, and I was supposed to contact them and let them know I was there. Well, I didn't know, but he didn't kick me out either. So he was nice. But either way, so go to the site where you want to go, the nearest city near the center line, and find a spot, because if you don't, someone else will find your ideal spot and you're going to have a lousy spot. And the nice thing is this one's at about 3:30, so the sun should be pretty high. Sometimes, when they're in more closer to the morning or the evening, you need to have a horizon without not a lot of trees or buildings, etc. Okay, so but try to do this. Eclipse glasses must be worn throughout the partial phases. Okay, I think I've said that to death. Taken off only during disappearance of the diamond ring when the corona becomes visible during. So here, partial eclipse, use filter. No eclipse. I mean total eclipse, no filter, and then partial eclipse, use filter. And look, the eclipse is this much, and people lose interest right after the eclipse. They're all drinking champagne and partying. No one's looking up anymore except for me and Fred Espinosa. It's amazing. So don't do that. Okay, that's my advice. Keep watching. Okay, it's okay to break open champagne or beer or something, but just keep watching so that it's till the very, very end. Okay, so tips for observing. This slide was courtesy of John Silason, who saw my, I sent him my presentation and he made some really good constructive comments. So this is thanks to John. And so if you stay at home, you will witness a partial solar eclipse for both eclipses. Don't do that, especially the total. Don't do that. Now, one great thing about the internet and the digital age is you can now watch eclipses via live broadcast, live streams, which is really cool. It's not as good as being there, but if you can't afford a trip to Australia, you could see it, you know, in at night, starting at 9:30, you know, in the comfort of your own home. So it's pretty cool. And there's several different locations. So if one is clouded out, you keep searching for a different location. An easy and safe method for observing partials is to place one hand finger over the other, like you see here. And this forms little crescent eclipses on the ground. So it kind of makes like a pinhole camera. Another thing is eyepiece projection. You can take an inexpensive refractor here, and then everyone can see this. You don't have to line up and look through the telescope with a filter on it. Or you can make this funnel, which is really eyepiece projection, but it's in the shape of a funnel. You put it here. So these are indirect ways of viewing the partial or annular eclipse. Okay, now
except the one thing to note, there is no eyepiece in there, just the funnel. You don't want to melt the eyepiece, right?
Oh, there's no eyepiece?
No.
There is an
Oh,
eyepiece.
okay. Well, I've never done this personally, so I don't know. Oh, that makes sense. Yeah.
I made one. I've got
You can
one.
do
It works.
You can do
really
it both
well.
ways, I guess.
There is an eyepiece at the bottom of
Yeah.
that. There's
What
actually,
there is?
there's
what I'm
actually
saying
a
is-
formula.
You can do it both ways, but make sure you're not using cemented glass that are in your eyepieces, or they could melt. It's cement.
Oh, okay. Yeah.
So if they're separated airspace, like what Chris was using, that's fine. That's what I was trying to get in, Chris. Sorry, we both stepped on each other.
Okay, yeah, no, yeah,
okay.
they recommend using metal, metal bodied eyepieces, not plastic.
Oh, okay.
So yeah, and there's a formula that a lot of sites will have for the size of the eyepiece.
Right.
Depending on the
You need
aperture.
an eyepiece here for the eyepiece projection, right?
Yeah.
That's what they call it, eyepiece projection. Yeah. Okay.
Yeah.
All right. So that's good to know, because I'm going to
Yeah.
be giving this to other groups too. So it's
Yeah.
good to know that you can do it either way with an eyepiece or without.
Strangely enough, my Tasco 60mm came with one of those black and white metal things, and they're all cemented plastic eyepieces.
Oh,
So it's not something I would never ever use, but except for the metal extensions, they were safe.
no, I
And
used one during the 2017, for a group of people. It worked really well.
Yeah, so just make sure metal barrel and non-cemented glass.
Okay, metal barrel and not cemented glass. Good, thank you. So continuing on the tips, when you buy these glasses, make sure there's what they call an ISO number. This one I got from NASA for the 2017 eclipse. They sent me 100 of them to give away. I still have a few left. And this one, I looked, this was given to me during eclipse. We went on Tahiti. And in 2010, and this does not say ISO. And the reason you want ISO is because it blocks both UV and IR radiation. So ultraviolet and infrared. So ultraviolet and infrared will see the visible is blocked 400 to 700 nanometers, but the UV, which is below 400, is not blocked, and the IR, which is above 700, is not blocked. And both can damage your eyes, your retina. So you want a blockage of those. So when you go to buy these, make sure that they're ISO certified. Okay, they have this number here. All right, and major manufacturers like Rainbow Symphony, Thousand Oaks Optical, Lund, Daystar, Beta Planetarium. All right, these will basically be certified. Okay, and then I say the same thing here. And then if you're not going to go, especially to the annular eclipse, consider outreach volunteering at a museum, library, or other facility with a solar telescope for the public to view the eclipse. They'll only see 20% from Connecticut, but 20% is better than zero, right? So $20 is better than $0. So, at least 20 is better. They'll see something, they'll see a little nick, and, you can tell them how exciting it is and try to reinforce going to the total eclipse the year after, okay? And then tips for observing. So I don't recommend this for you guys because you're all seasoned astronomers, but do not attempt to photograph during your first total eclipse. Okay, everyone says this because what happens is you'll require expensive equipment, large focal length lenses, and you'll be fiddling around with your equipment and you miss the excitement of the eclipse. Okay, and if you look here, a 200 millimeter lens, which is not really that big, okay, that's how big the sun will appear on 35 millimeter film, or well, now it's digital, but still that'll be the size. You need at least 500 for it to be any decent size, okay? And then 1,000 here, and then 2,000 is, an 8-inch, and this is a 4-inch, and an 8-inch 2,000, the focal length is 6.5 feet. That is 2,000 millimeters, 6.5 feet. So, you're not going to get things this big. So 500 is the most you're going to get. And focusing, and then when you focus during the partial phases, okay? So you'll have plenty of time to do that, use a solar filter. And then as John Silason mentioned, Eclipse Orchestrator is a program that automates your DSLR. I have absolutely no experience with this. So if John knows, talk to him locally, he'll tell you how to use it.
Well, I spent a week with Fred one day.
Yeah.
At Solar Fest USA. And he was pretty adamant that you don't do this eclipse photographing, even with Eclipse Orchestrator, on your first eclipse. You've got to get experience with the eclipse and the software. And that, again, just like you said, not your first time, but I did both white light and
I know
and
very few people listen to that. They do it
Yeah.
anyway. But you only have 3 minutes and 50 seconds. You have less than 4 minutes to see this beautiful corona. That's it. The
I
rest
was
of
with a group of 3 of us, so we had plenty of time.
Yeah, so during the partial phases, you have plenty of time to play around with exposures. During the partial phases, I recommend playing around with the f-stops and the exposure time. Well, it's going to be like that, so you're not exposing for seconds on end. Okay, it's a snapshot. So figure out 1/60th, 1/90th, 1/125th, 1/250th. Go 1/1000, and you'll see it'll get dimmer and dimmer and dimmer. And you'll figure out what's the ideal exposure. And as the sun gets more, from a larger disk to gibbous to crescent, you have to increase the exposure, because there's less light, so you need to expose a little bit longer. But either way, but what I do is I do video. I don't like doing photography because you relive the experience all over again. And what's cool is when you go with a group of people, to an exotic place. Like my first solar eclipse that I saw was in '94 in Bolivia. All right, so we went to the Altiplano. We were way up. We took a train that took several hours to get up there, and so I had a video through the telescope. And then when we came back to the hotel, everybody's showing one perfect picture that they took, and everyone's like, oh, wow, nice. And then I show my video, and everyone starts going, oh yeah, man. Everyone starts like freaking out again, like they're reliving the eclipse. And people are saying, damn, I should take video too. Nobody. So now you see more and more people, especially now with the cell phones, you can put a telephoto lens on it, and the go-tos, those go-to pros that people have on there, on their hats and stuff. It's much, much easier to take video now than it was in the past. Okay, so more people are taking video, and now with not only HD, which is 2 megapixel shot, but now 4K, which is an 8 megapixel shot. So this is my 4K camcorder. Okay, and this is a Star Adventure little equatorial mount, and then I have it on a carbon fiber tripod. And I keep it very low to the ground, because if you keep it high, it unbalances, and then a lot of times there's wind, and that'll cause it to move. So if you keep it low to the ground, it's good. And then I usually look through here, so I can, because it's very bright out. And see here, I have a Thousand Oaks optical filter, and that just pops on and off. So during totality, I pop it off, and I'm looking here, and I'm trying to look up and here, and it's tracking pretty well. So I don't have to look here, but I have to adjust the corona, so it looks pretty nice. And then once the diamond ring comes, pop the filter back on, and just keep going. So it's real. And then I can take it. So instead of a photo, I have a screenshot, an 8 megapixel, photo, which is pretty decent resolution, so better than the 2 megapixels. So I like to do video. So if you can do video, do video. If not, take photographs. And then another thing to do is, like I said, photograph the surrounding area during totality. Oh, they tell you do not use flash, because that will wreak havoc in people's photos. See, look at that. Isn't that beautiful? See, it's some exotic place here, like Hawaii or Pacific. And then here you have some nice buildings. Isn't that beautiful? But the problem is it's so tiny, when you do that. And so here's another tip. Use an umbrella to shadow yourself from direct sun. So I always keep an umbrella on top of me, and plus it makes shades. So when you're looking at your screen here, you can see it a lot better, okay, because it's not in direct sunlight. So have an umbrella with you. You'll be surprised how it keeps you much cooler. Keep hydrated and wear sunscreen, okay? Bathroom break before totality. This is important. When the sun is about maybe 80% eclipse, run to the bathroom with a porta potty, wherever, it's probably out in the middle of nowhere, and go number 1 or 2, because you don't want to, totality's happening. Oh God, I gotta go. It sounds funny, but you can't have a full bladder or bowels, during totality. So make sure you get a good bathroom break before. So clouds will obscure the view. So be prepared to move to clear skies if necessary. The 2017 eclipse, we were in Nebraska, and it was cloudy the night before. And so we had to travel like 100 miles further out, closer to Wyoming, to see it, because the weather prospects were bad for where we were. And some people stayed because it was a nice motel. And I went on the bus and went out there. And we found out that the people that stayed, it cleared up there too. So we didn't have to go. but I didn't want to risk it. So I went on the bus. And then that was one of the times when it was about, 70, 80% still phase, still had about 30% to go. We had to get back on the bus, so I couldn't see it. So I'm at the window taking, video of it while the bus is moving, the partial phases. All right, and then here's the temperature drop I was talking about. Bring one of these with you, hydros. I bought this on eBay, and look at this. We were June 21st, 2001. There was an eclipse in South Africa, and notice the temperature was about 85 when it started, and then during totality it dropped to 50. It dropped 35 degrees. Can you believe that? And the same thing happened. We were in a tree fall that we slept in with mosquito netting. And in the morning, it was 30 degrees. I had this out there. It was below freezing. And then by afternoon, it was up in the 80s. I mean, I couldn't believe it, how cold the African savanna gets. But look at that, went from 80 degrees down to 50. I mean, so your shorts and a t-shirt, and then here you need a jacket or a sweater, you know. But so total eclipse is one of the ultimate experiences of a lifetime. So don't miss it. So any questions? And that's it. So, any questions?
Why don't you leave out that list of websites for people for a few minutes while you take questions there, Greg?
Okay. 1 hour exactly.
Ah,
All right.
Greg, will this
Yeah.
PowerPoint be available that we can view it on our own time?
Yeah, I think I sent it to you.
You've already got it, Robin.
Awesome.
He emailed it twice. First
Okay.
time he thought he was just emailing it to me and to Chris, and he sent it to the entire
I
ASGH
could send
group.
it again.
No,
Fantastic.
that'd be 3
Yeah.
times. He sent it out yesterday too, or this
Great.
morning.
Great. Thank you
Yeah,
so much.
check it. Yeah, I sent it. So, but definitely go. This is not a very technical talk. It's more of a get excited and go see the eclipse talk.
Tell me,
I'm glad you mentioned the June 21st, 2021 eclipse, because that's kind of the poor cousin that never gets mentioned. But I was actually up in Granby photographing that one at like, what is it, like 6 in the morning? We had it here, you know, partial eclipse at sunrise.
Even the documents should flow
There were a few of us that were lined up and taking photographs of it.
when everyone else was back.
So here's my somebody's so here's all the eclipses I've been to date. Okay, see, this was clouded out, this was snowed out. I went to Mongolia, believe it or not. Yeah, look at the places I've been to. I mean, travel. And then and I traveled to see both. My wife and I traveled to see both transits of Venus in Corfu, Greece. I actually have relatives there, and I stayed with them. And then Maui, Hawaii. So I had 11 total solar, 75%, 3 annulars. I saw all 3 and 2 transits of Venus. And this is the Saros, the 2009 of this one. These were 7 minutes, and this was 7 minutes. So I got clouded out on both of those.
you went to Greece for the first transit?
Yeah.
Wow.
Yeah,
Well, that's true. You weren't in Connecticut or Rhode Island then, were you?
No. I left Rhode Island 1990.
We went to a golf course over by the Rogers Apple Orchards at like 5 o'clock in the morning to set up.
Oh, wow.
And
You could see both of these from New England. What was it during sunset? I think, right?
yeah, I guess from what I heard, the weather was bad for the 2012 one. We were out in Boulder City, Colorado.
Yeah,
Oh, okay,
yeah, it
good.
was cloudy here.
Yeah,
You
and
didn't
the
do
thing about
Did you do the Mercury transit?
yeah, I've done the Mercury. I didn't write them down. I did a lot of the Mercury ones because I could do them from my front yard. You know what I mean? So I didn't have to travel at an exotic place to see it. Actually, I'll include those too. But yeah, but the thing, this was perfectly, the Corfu one was really nerve-wracking because what happened, I have, my mom's from that island, and I went to visit my relatives. I stayed with my aunt there, and we went there a week, about 10 days earlier, and it downpoured rain for 7 days. I was
Oh,
freaking
my.
out. I wanted to go to Athens, and my relatives were mad at me. You can't leave us and all this. And then it cleared up the night before the transit. It was perfectly clear blue skies, and the day of, it was a mirror image of that day, perfectly clear skies. I mean, it rained for 7 days, so it was like there was no precipitation left. So I saw the whole thing beginning to end. And then June 5th, the 2012, there were a lot of clouds going by during this one, but I got to see, it for 30 seconds, and then clouds came, and then another 30, all different times. And then by the time it was setting, it was perfectly clear, so I got to see a lot of it there. But this I didn't see as well, but I did see quite a bit of it. So this one I had HD technology existed then. This one was with mini DV, all the different technologies back then. But any other questions?
I was going to ask if you could leave up that website of Eclipse information for people to look at while you answer questions.
Oh, yeah,
It
sure.
was your last slide.
Okay, just,
Well, that'll
I
be in
just
the
wanna-
PDF that, right?
Oh, that's
yeah,
true.
oh, yeah, it's in
Thank
the
you.
PDF, yeah. Yeah,
Sorry.
it's in the PDF. And let me see. I want to share one other screen. If you want to see my eclipses, just go to YouTube. I have them all here, and type in Greg Shanos solar eclipses. Seeing they're here.
Greg, that was not a solar eclipse. That was the Chinese balloon.
What?
Don't take credit for that.
Oh, that one, I know that's just other things, but where it says my name here.
Yeah.
But that's the so you could click on them and listen to them, but it's really cool. Stop share. I could put the presentation back if you want.
That's all right. I forgot. It was in the PDF you
Yeah,
sent
yeah,
to everybody.
it's in the thing. So
Thank you, Greg.
So that's
Any
all
other-
I have. And
Any other questions from anyone?
This is a really good presentation, Greg. Thank you.
Yeah,
oh,
thank you.
you're welcome.
Very
Thanks.
complete.
Yeah. Oh, here it is. So if you want, those are some of this one's updated for the 2024 one here. It gives and you can zoom in. What's cool is if you go to the website of this is listed there. You can zoom in on all these states and really zoom in and see the cities and where everything is, so you could pick the spot you want to go to. So that's what's really cool about that. This is
One comment that Greg mentioned, but didn't give us good information on how to, is he suggested researching the climate for the area you might be interested in to
Right.
visit. Fred Espenak and his team have the Great American Eclipse website. I think it's your last slide. I think it's greatamericaneclipse.com. He sells magazines or books, magazines, greatamericaneclipse.com. I was right.
yeah.
They sell
Oh,
books, which are, no more thick than a magazine for the upcoming eclipse or the next 10 years eclipses. One of them will be a roadmap, and the other, and then break it down by section. It'll tell you how many days of cloudiness they had on the average for the last 10, 15, 20 years, or however long they've been keeping weather data for that location. So for each state or each piece of that path, they will have that information for you. So
Yeah,
it's a really useful resource.
This is Fred Espenak. He calls himself Mr. Eclipse,
He does.
MrEclipse.com. That's his website.